I had a quite interesting idea yesterday while eating some Thai food with my wife and kids. So I had been working on a blog post on AI safety where I try to give my best logical, rational argument as to why an open and decentralized network wouldn't actually be suicide for our species, right? And why it actually probably, given the real geopolitical situation, is going to be safer than having AI under some sort of realistic lock and key within a big company or a government research lab. And I'm not going to repeat that whole AI ethics article here. You'll see the blog post. But one of the main points that came up there is, how can you decrease the forkability of a decentralized AI network? So if you have a big, like, global intelligence running across your whole decentralized network, how can you make it so it's hard for someone to just clone a small portion of the network or fork off a small portion of the network and then make their own nasty AGI? Like, I'm happy with people to fork whatever I'm doing if they make something cool with it. Like, my AI work is pretty much all open source. I publish all my ideas online. But when you're talking about an AGI with strong capabilities moving quickly to superintelligence, you've got to think twice about, what other sorts of entities might fork what you're doing for their own good. And the global AI brain I'm thinking about wouldn't be my thing, it would be everyone's thing. And you'd want everyone's thing to be more powerful than anyone's thing, right? And you don't want people to be able to just take what the global brain has shaped, like fine-tune out the beneficial goals and fine-tune in their own selfish or nasty goals, right? And in that blog post, I highlighted this as a weak point. I mean, I still concluded that, the weak points of centralized control are worse, but I was thinking about, how do you work around this weak point in the argument for beneficial, open, decentralized AGI? Then, my brain kept churning. Within a day later, I came on a technical idea that seemed like it actually could work. And of course, in the big picture, this is nothing surprising. It comes right out of the infrastructure we've been building. Like the new notion that pops into my head, it's a perfect application of our meta language being both our AGI language of thought and the smart contract language of our blockchain, the ASI chain blockchain that we're in the process of rolling out, right? So, I mean, this is all, it's not like I decided we need to build quantum computers in a cup of water or converted to a deep neural net only guy. But still, the details are falling into place. Some of them are big details, and they're quite interesting things in themselves, right? So, first point, what you need is what you might call super additivity, right? So you need the whole to be more than the sum of the parts. You need the whole to be able to do things that no practically stealable part of it can do, right? So as long as you have an enormously powerful global decentralized system and the riskiest, most dangerous capabilities don't fit inside like a copied shard or a copied small subgroup, right? So super additivity is all over the place in our Hyperon AGI design, right? Like, it's there in algorithmic chemistry, it's there in evolutionary programming with multiple modules. I started thinking about one particular locus for super additivity that seems especially critical, and this has to do with logical reasoning. This is one key thing large language models aren't good at doing is grounding the reasoning in the real world, right? And our PLN, probabilistic logic networks module in Hyperon is designed for that. It's designed for bridging mathematical and scientific reasoning with common sense, everyday stuff about the real world, social stuff, perceptual stuff, linguistic stuff like LLMs do. And we're using PLN now to help our Max Botnick Omega Claw agent think, and the soon-to-be released benevolent army of other Omega Claw agents. We're using PLN reasoning in the Rejuve Bio product to read about biological data. Any time that you're dealing with sort of conceptual linguistic thinking plus some other body of harder data like software code, be it inside Max Botnick's brain or your own code project, or biological data, financial data. Anytime you're dealing with that mix of fuzzy linguistic stuff with hard scientific stuff, PLN can do better than large language models or than traditional machine learning or crisp logical reasoning systems. So I started to think about, where does the superadditivity live in PLN? It's going to live many places, but one place where it lives a lot is inference control. So inference control is a part of a logic engine that chooses, out of many, many next steps for logical reasoning to take, it chooses which step to actually take, right? And that's actually the hardest part of building logic-based AI. It's not making computers do step-by-step logic. Computers are good at that. It's not telling it what kind of logic to use, because you don't even have to decide. There's many flavors of logic, and like in our meta language, it's very meta. You can code any kind of logic you want, and it can do most of them reasonably efficiently, right? But choosing what inference step to take next, this is the tricky, like AGI scale problem, right? And you can't just write a rule or a heuristic for that. You can't get a completely throw a mathematical formula for that. Inference control has to be learned. And we've seen that for decades. We just haven't had the scalable infrastructure to experiment with it. Like inference control has to be statistical and historical. The system does a bunch of slow, dumbass reasoning. It learns what worked and what didn't work from that slow, dumbass reasoning. It gets some successful patterns out of that. Then it uses those patterns to guide its next phase of reasoning, and sort of a lather, rinse, repeat, right? And as it does this over and over again, it gets smarter and smarter at learning to choose what inference steps to take, right? And this is a complex, chaotic process, and it can happen over and over again in different domains. You can learn how to reason in biology. You can learn how to reason in finance. You can learn how to reason about fly genes. You can learn how to reason about love. You can learn how to reason about war. Then you can merge what you learned about how to reason, how to do inference control in these different domains. You can merge these together into overall inference control heuristics that hold up across multiple domains, right? So this looked to me to be a super interesting nexus for making the superadditivity decentralized and hard to fork, because it's clear the inference control heuristics you learn from putting together inference control patterns in multiple domains and kinds of problems. This is super additive, right? Because you're getting abstract inference control heuristics that embody, deep knowledge beyond any individual domain, and you can do some math to show why inference control heuristics should be super additive, right? The detached copy that only knows inference control over some little domain is not going to be as clever. And so that's the direction I start thinking in. But of course, this doesn't give you the security we're after, because there's an obvious objection, like why doesn't some bad guy just copy the learned inference control heuristics, just like copy the general patterns for inference control that pop out of putting together the inference control heuristics from all over the different network, right? And so that led me to a notion I labeled cryptographic laterality. Like, this is where the blockchain comes in, right? So you don't store the dangerous high-level, omnidomain inference controller. You don't store that as a single object anywhere, right? You use cryptographic secret sharing. You break the inference control object into little pieces spread across the whole network. So your knowledge is spread across the whole network, right? And we're already doing that. The atom space, which is our weighted labeled dynamic knowledge graph inside our Hyperon AGI engine, right? The atom space has a distributed atom space infrastructure. It can be splayed out on the ASI chain. You can have bits and pieces of the atom space on many, many machines all over the planet, and the thinking is occurring in many, many machines all over the planet. But you can also put the, omnidomain inference control patterns learned through history split up all over the planet, like put the high-value inference traces, the policies for merging stuff from different inference control heuristics on different domains, the critical mid-level atoms connecting abstract patterns with low-level particulars, right? You split this all across many, many different nodes, and then you can evaluate it through, secure multi-party computation. Evaluate it through MPC implemented in ASI chain that reveals to the inference engine only the next needed control action within certain bounds. So you use secure multi-party computing across the different nodes in the network to allow the inference agent running in one node in the network to leverage knowledge from all the other nodes in the network to figure out what to do next, right? So the overall inference controller is never decrypted and then run. It's not in plain text anywhere. There's no model file to steal and no log directory to copy, right? Like the intelligence is not an object at rest that you can capture. The intelligence is an event that the network as a totality performs, right? So if you have a bad guy who wants to fork off and copy the intelligent thing the global network is doing, like, their job isn't copy and run. They have to do something much harder. They have to corrupt, a whole big coalition, or they have to distill this moving target through outputs that are being monitored, or they have to rebuild like this whole, global brain, this whole civilization scale AGI substrate, right? It's not to say it will be impossible for an attacker to do anything, but it's going to be much, much harder than if you don't have the inference control policy distributed across the whole network in an encrypted way like this, right? And the new notion that I had was the secret sharing bit using multi-party computing between the individual nodes embodying parts of the overall inference control policy corresponding to parts of the overall knowledge base, right? And so I've been working at a bunch of math of this. I'm not going to try to say the math now, but I would say, well, I've been working this out in the context of inference control. It can be done in the context of many, many other AI algorithms. Also, this is kind of the sort of thing we've been grasping toward with SingularityNet since the beginning, and it's the sort of thing that we were thinking when we made Meta, both our AGI language of thought and the smart contract language for our blockchain. This is what ASI chain meets Hyperon is supposed to enable. I'm just starting to see now the exact ways that it pans out technically, right? Very, very interesting, right? And the thing is, you don't buy security here by making the system stupider, right? And you don't buy security by building a fortress and burying everything behind opaque central control. It's because there's going to be a lot of different ways to do inference control that are all smart, just like there's a lot of different ways for people to be smart And then we're choosing a way to make the system smart that happens to splay out across the entire network in a way that can be secured via multi-party computing, right? And we're also not trying to do all the reasoning using strongly encrypted operations. Like even using meta, that will be expensive. In meta, you can do operations on or off chain. You get to choose which or which, right? So we do most of the logic, statistical mining. We do all that off chain using meta. It's only the very thin, especially high value inference control choice layer that we put on chain and use MPC for. Everything else is fast and done in a normal way. But what you get there's critical capability that people would have to do something bad and dangerous. And this critical capability is not a thing you can grab and carry away. This critical capability is a live computation that a whole distributed substrate has to perform, right? Which is a very beautiful and clear notion of non-forkability in a decentralized AI network. I've always said decentralization doesn't in itself fully solve anything, but it opens the door to a whole lot of creative solutions. And this notion of cryptographic laterality for inference control and other core AI mechanisms, I mean, this is the kind of thing that we need to build into our network, which it's the kind of thing that our decentralized AI infrastructure has opened the door to. And it's going to be fun to work out all the details and see it really running.